Hi guys, well thank you for joining me. So first of all, a little bit about myself. My name's Bourne. Sort of full disclosure, I work for a cybersecurity or an enterprise cybersecurity company called Vanify. We're about sort of 15 years old, and we work with pretty much most of the G2000, where we basically help them, well, traditionally help them secure their machine identities and X509 keys and certificates across their sort of traditional infrastructures. Obviously, what we're starting to see now with the shift towards DevOps, automation, containers, digital transformation, and all these wonderful new technologies that are starting to emerge, is that DevOps teams need to consume keys and certificates, but this time a lot faster than the traditional teams. So you guys obviously are, hence you're on this talk, obviously know all about DevOps and speed and agility and the fact that you ultimately need keys and certificates quickly. So the goal here really is to, as we'll step through this, talk about how enterprises enterprises that implement centralized key and certificate management services can still play a part with the DevOps teams and enable the DevOps teams to go fast and provide them with the machine identities or certificates that they need in real time. So really the goal is to sort of shift enterprise security from being a traditional bottleneck and a pain to deal with, if you like, into something that is actually benefits both enterprise security and the DevOps teams. So and just make your lives a lot easier so that you don't have to worry too much about building certificate authorities, wondering who's going to sign those certificates, who's going to control that certificate authority, and all those things that typically sort of the corporate enterprise PKI teams took care of. So we've got two sessions. One, I'm going to cover Terraform, HashiCorp Terraform, and the other one is HashiCorp Vault. And we've got sort of two integrations into a centralized key and certificate management platform that we're going to show you. So very quickly, in fact, let's just sort of walk through the problem a little bit first of all. I think it's fair to say, if you look at X509 keys and certificates, they are pretty much the only real option still for identifying endpoints and securing the communications between different endpoints and machines within an infrastructure. And as I sort of touched on a minute ago, the transition from sort of monolithic apps to new technology stacks, ephemeral microservices, and all these new things present some of the DevOps and probably even more the security teams with even bigger challenges. And certainly my experience with talking to enterprise security teams is that they just don't know what to do. They're struggling to keep up with demand. And that I can vouch for that from several of our big financial services customers. The other thing that one should be aware of within the enterprise, and you know, I think for sort of greenfield type startups and new sort of fintechs, probably this could be less of a problem. But as they get larger, this problem will maybe start to manifest itself. Is that because they're subject to very strong audit requirements and the ability to maintain visibility of control, and sometimes these banks have highly restricted certificate or PKI signing services within their organization. And then also that's mandated quite often. Some of the big, certainly with some of the big French banks I work with, they mandate that all certificates are signed within a certain environment. So you can't just have arbitrary signing services running in different parts of the infrastructure. So that again is another challenge for the large enterprise that are trying to sort of do DevOps and digital transformation quickly. So what that sort of often leads to, again, is, you know, if DevOps decide that there's a bottleneck, quite often they'll bypass that. They'll bypass the enterprise security controls. They then start building silos, and those silos of certificates ultimately potentially become unmonitored and unknown. And then that starts to cause, initially starts to cause audit and compliance issues, and worst case, potentially can start to cause outages across some of this infrastructure. So we're going to talk about how we can help with that problem. And first and foremost, we're going to talk about how we can integrate a sort of infrastructure as code framework, such as HashiCorp Terraform, with an enterprise platform that could already be implemented within the enterprise, or it could be certainly something that enterprises are looking to implement as part of their enablement for DevOps teams. So first one, as said, Terraform. It's implemented as a custom provider. So those that know Terraform know that you can customize and build additional extensions to Terraform. So it's implemented as a single binary file that sits alongside the Terraform binary. Simplifies the procurement of machine identities for developers using Terraform. I'm not going to read out all of these, but ultimately it enables you to then define issuers, certificate issuers within your Terraform plan files, and then ultimately inject the keys and certificates that are procured through that issuer into the various parts of the plan. And the demo we've got here should go off, connect to our backend service, which I'll show you very briefly in a minute, issue a certificate, and then start up a little sort of Nginx demo in a Docker container using that certificate. So no interaction whatsoever, fully automated end to end. And once that happens, it's very easy then to leverage other HashiCorp technologies like Console to potentially monitor the status of that certificate. So if it looks like it's going to expire, then that Console process could kick in and initiate a replacement, or reinstantiate maybe another container with a newly requested certificate. So again, fully automating this whole life cycle. So a little bit about the architecture. This is what we have running. So you can see here on the left-hand side, we've got some of the typical Terraform components, little Terraform console that sort of is driving this for now. And then obviously, as you guys that know Terraform already know, it supports multiple upstream APIs. A few examples there: Docker, Google Cloud, Kubernetes, AWS, and Azure. And then the back-end sort of PKI services have now been routed to this sort of centralized Venafi service, which is a corporate sort of or enterprise-wide central key certificate management services that can be wired into multiple CAs, and those CAs can be internal or external, or any certificate authority that's either already in use within the organization, or it's very easy to find connectivity to a new one. And the Venafi platform ultimately pushes out policy, provides audit reports, audit controls, maintains visibility because it has a centralized inventory of all keys and certificates across the entire organization, and really wraps up all of that into a sort of nicely consumed REST API. And then that's what's used by this Venafi PKI provider that we have plugged into our Terraform environment here. Okay, I'm going to give you a quick look at the back end very quickly. This is how it looks. I'm not going to spend too much time on this. This is one I was testing earlier. I'm just going to remove this. So this is thing here that you can see, this Vault demo. This is a policy container within the back end. I'm just going to delete that now so we can sort of see something happening. And this is really where we would sort of set all of our enterprise controls and policies and things. So the nice thing about this, your Terraform developers and Vault developers don't really need to worry about this, because this is all something that gets provided by corporate PKI, corporate security teams. And there's a whole lot of stuff you can do in here, such as defining sort of typical X509 attributes, deciding which certificate authority things get routed through to, etc. So as I said, let's not worry ourselves too much about that, because that's the whole point of this presentation. Okay, so let's take a look how that looks for real. So if we scroll down here a little bit, incidentally, those that want to look at the project for real can go to GitHub. This is a GitHub repository. It's called Venafi Vault PKI backend -Venafi. Okay, so you can find out all you need from there. First and foremost, you can ignore this. Those that know Docker, to expose the Docker API as a little hack there, so let's ignore that bit for now. So this is an example of our Terraform plan file, and really all we're doing is providing that the Venafi provider service is available alongside the Terraform binary. This is how we define our connection to our sort of back-end certificate services, enterprise certificate services. So we provide here, obviously a URL. These things here, by the way, they're in the plan file, but in reality, you would probably use Vault to store those and secure those. So they wouldn't be sitting here in the clear in a file, obviously bad practice. And this final thing here, this zone, is the policy that is referenced, because the back-end service can expose multiple policies, not all of which you would have permissions to access. So you need to specify that here, and that gets set there. So that's really all there is to it. And then once that's defined and set, you can just create a verified certificate resource within your Terraform plan. And here, because the back-end platform is taking care of everything else, all you really need to provide is the common name. And in actual fact, these things here are also defaults. You can probably take those out if you wanted to, but really you just need to provide that and some subject alternate names. I'm just passing in a couple of others here. Call it, yeah. So we've got a service one, and then we've got some wwws and some other names, DNS names that we're passing into the certificate resource. And then once that has happened, you ultimately get three things that get made available to variables within the Terraform plan. So one is the certificate that comes back. One is the certificate chain. And then the final one is the private key. So three variables that can now be referenced anywhere else within your Terraform plan. And then for the purposes of this demo, we've just defined a Nginx Docker container. Yeah, so you can see here, resource is Docker image Nginx. It's using a little custom Nginx build that I've put out up in the Docker public repos. Some configuration information, and then finally, before the container starts itself up, we just literally push the, and there's a number of ways of doing this. You can actually use, obviously, the Terraform upload directive to push the keys and certificates into the container before it starts. This is how I'm doing it. You could decide that actually you're just going to mount those keys and certificates as part of the container mount and have the keys and certs stored on the Docker machine in the file system. There's a few different options, but this is the one I'm using for this demonstration. And then we can try this out. So that's the plan file we're using. Just going to change directory into that directory so that we're in the right place. And if we just do the dry run, we can run the Docker, the Terraform plan command. Okay, everything looks good. I'm not going to spend too much time on that. Those that know Terraform will know all about this. And then, ignore that, we're then going to try it out. So let's give this a go. So first and foremost, let's just jump into a terminal. Just make that a bit bigger for you. So we're just going to do a Docker PS, see what's going on there. Right, we don't have, ignore the containers that are running. We don't have an Nginx container. Let's try this. We're going to auto approve. Demo gods being on our side, hopefully all will go well. This is a live demo. So you can see here it's started to create the container. It's now created the container. It's now requesting the certificate through the PKI backend provider that we've plugged in. Hopefully this is all going to go. So creation complete. And hopefully we're going to dump out the output to the screen so you can see from the screen what we actually get back. In real life, you obviously wouldn't do this, but we're just squirting it all out so you can see something interesting happening. Give that a couple of seconds. Things seem to be going a little slow this morning. I don't quite know why. Whilst it's doing that, I'm going to jump across to the back end and we can just do a quick refresh here and we can see what's going on here. And hopefully, things are going slow this morning. Let's expand out this. Okay, so you can see here, we have our service one. So it's actually created the certificate. Let's just make sure that it's got a proper sort of fulfillment of that. We should see in a moment what comes back. I'm going to delete that one because I don't need that for later, but we'll come back to that. Let's just jump back to see what we've got here. Yeah, things seem to be going slowly for some reason this morning. That should have happened by now. Okay. Okay, I'm going to leave that because that should come back. I don't quite know why it's taken so long, but as I said, this is a live demonstration. What I'm going to do now is I'm going to move on to another demonstration. I'll come back to that one and hopefully that will happen. For some reason, things seem to be running slow. So this goes against everything I just said. Corporate security slowing down DevOps, and that's exactly what we're doing here. So ironic. Anyway, let's move on to this one. We're going to talk about here integrating HashiCorp Vault with the same backend service. So this is a sort of similar integration where we've implemented Vault as a custom PKI backend. Implemented Venafi rather as a custom PKI backend to Vault. Okay, so the really the purposes of this is that it really just simplifies and makes it really, really easy for Vault developers to get keys and certificates directly from the Venafi or the centralized certificate as a service backend within an organization. So very similar to the Terraform integration. DevOps teams don't really need to know any new syntax or anything new. They've got access to this plugin. Security teams can pretty much do everything that is needed for them at the back end. So I'm not going to go through all of these benefits right now, but let's just look at the architecture. High-end overview of the architecture here. We have this plugin into Vault, and what we're really saying here is that any request for a certificate made to Vault now gets redirected to this centralized backend service within the enterprise. And then that request gets fulfilled and then stored within whatever storage backend is configured within Vault. So we send, you can see here, a signing request, we get back a certificate, and then the private key and the certificate get stored in Vault securely, ready for use within any of the applications that you want to use within Vault. Okay, project for this one is stored here. Okay, so we've got GitHub Venafi Vault PKI backend. So again, you can download and use that today. Those of you that are using the sort of Venafi backend, that's available to you today. This stuff is just Vault setup stuff, a couple of environment variables and things so we can access the Vault. Take a look at the Vault status first of all. Yeah, we have one. And then just like we did in Terraform, we define what we call a role within Vault, and there's a sort of some metadata that we configure and store within Vault. Obviously the URL to the back end, this time the username and password secured within the Vault, the policy that we're referencing, and some other metadata in here, which I won't cover right now, but that's how we define the issuer resource. Let's just do that. And you can see that's now been written to the Vault. So we've got that ready to access. And we can take a look at that if we want to. We can get help on that too, by the way. So we can click that and that gives you all of the different options that you can specify. And then we're going to scroll down here a little bit. Let's just read that back and see what happens. Okay, so you can see that that's stored. And requesting a certificate is really as simple as issuing a Vault write command, but we reference the Venafi PKI backend here. And then we just pass in some additional data, common name and some subject alt names. And again, just like the Terraform backend, we get a certificate back based on a centralized policy that's been defined and controlled by IT security or corporate security team. Right, so let's give that a try. We're going to make that request. Hoping this one will work too. Why that one's gone so slow. Oh, that one eventually worked. It was just very slow. I'll come back to that one. I think maybe the network's all slowing down because everyone's watching these HashiTalk conferences, the internet's slowing down. So that worked a lot quicker. There we go. So we've got back now into our vault. We can see here, we've got a unique ID for the certificate that's been requested. We've created a lease value. Now, this is really useful. This can be used by, again, I mentioned the use of console for replacing or renewing certificates. So if you're issuing short-lived certificates, this one's about 5 minutes, 29 seconds. That's a pretty short-lived certificate. You can use this value for renewing. So the template, the console template can be used to determine that this is going to expire within 5 minutes. And essentially restart the issuance of a new certificate and restart a service so that it doesn't cause any outages because the certificate's expired. So this is purposely set low so that you can sort of see this working for real. In the real world, you probably wouldn't set it as low as 5 minutes. And then this is our certificate. Again, I'm sort of dumping it all back to screen. This is our chain and this is our private key. Okay. And all of that has been written into the vault. So if we just list what we've got in our vault now. Okay, so we've got a couple of certificates. This is the one we've just requested. Okay, test 10. Just make sure it was that one. No, it wasn't. It was service 2. Or service 2. Service 2, sorry, it was that one. Service 2. And then we can get that out. If we want to read that now, you can just use standard vault commands, vault read, and we can pull the certificate out of the vault for use within an application. Okay, we can get the private key if we want to. There we go. It's as simple as that. And if we jump back across to our back end and refresh, we can see in here we have a service 2. So that's the certificate that's been issued according to our corporate security policies. Okay. And this is another demonstration, which I'm not going to do now. Really, this starts up an Nginx instance like we did with Terraform that can then use that certificate that's within the vault. And then if we use console to manage that process and control that process, console will detect that the certificate's going to expire and ultimately restart and rebootstrap that service to get a new certificate from the platform. Okay, so I'm just going to jump back to our Terraform demo, which has now worked. So you can see here, okay, we've got, and we're dumping everything back. We've got a certificate, we've got the chain, we've got everything else. We've got the private key. We're just writing this out to the screen for now. And let me just jump back into Docker now. I'm just going to issue a Docker command. And we should see, hopefully, that we have an Nginx service. We do. And it's listening on port 443 on localhost. So if I open up a browser, I should be able to connect to that. And see that we have a certificate on this. Not trusted because I haven't added it, but because it's a demo CA. But you can see here, this is the name of the issuer. So it was a demo CA that is issued this. In fact, it should be trusted because if I just do this instead, this may work and then we should get a real certificate. Try the other name. Yeah, there we go. So that's a certificate now that's been issued and it's valid. So at this point, that sort of pretty much ends my short talk, and I'm going to sort of open the floor up to questions for the last 5 minutes.
Thank you so much, Carl. That was incredible. And the demo gods were good too.
Almost. There was a glitch.
So we got a couple of questions here. So we have, it's in the participant chat, not the Q&A. Let me just try and find this. Is this dependent on running the Acme protocol on Venafi? No.
So we have our, I mean, it could be, we do have an Acme protocol service that we expose, but we don't have to, we don't use that here. The plugins, both Terraform and the Vault plugins, both leverage our REST API.
That's awesome. And the Vault plugin is pretty neat. Is that 100% written by yourselves?
Yes.
Awesome.
Yeah, so we wrote both of those. We have done other things through partners and things, but these two we consider to be sort of first-class integrations, if you like, that we want to do ourselves.
It's a really nice integration. It's sort of keeping that consistent workflow.
Yeah, absolutely. Yeah, the goal really was not to change anything within, we didn't want to reinvent the wheel. Other companies have done and tried to create their own solutions, but certainly, when we speak to our customers, they love HashiCorp products, and we thought, well, let's, enable them to use the tools they love, but just enable the enterprise security teams to sort of still do what they do well. So that's really the whole sort of philosophy behind what we've done here.
So we have just one more question. I think it's a follow-up. Is there an assumption that I'm storing certs in Vault or Venafi with Vault as an abstraction layer?
Good question. It could be both. And it depends on your corporate policy, security policy. So we can work in two modes. I mean, the certificate ultimately would be stored in Venafi and Vault, because obviously we can track it that way. The private key part of it is optional. So you can decide to store that within Venafi and Vault. Some organizations want to do that. And if you configure Venafi to integrate with an HSM, it's quite a common practice that they store a copy of all the private keys. But for some organizations that mandate the fact that there can only be one private key, that gets stored in Vault only, and we only see the certificate.
Awesome. Carl, I want to thank you again. Really nice presentation, and keeping up the standard of some great talks today. Thank you again. Thank you so much. And thank you, everybody.
Thanks, Nick.